Hey there, Sevens. So I have an intro into the next activity we'll be working on today. And in this activity, we're talking about this data set that you see over here, and we give the context over here. And this is it's the same context when you begin today's assignment, you'll see. So the owners of a gym have been keeping track of how long each person spends at the gym. 800 of these times in minutes are shown in the population tables located right over here to the right. So these are 800 times that people have spent. So this is some guy who came into the gym and spent only 16 minutes. I don't know how that worked, but he got his full workout in, felt good about it, left in 16 minutes. As opposed, we have like a bunch of people spending time in the 40s, 50s. This guy spent 84 minutes. So we have a lot of different types of data values here, but all in minutes, the amount of time people spent in the gym. Good. So if we look at the values, can you find the longest time spent and can you find the shortest? Like I was already kind of trying to ballpark that. Can you do it? How long would it take you? Or on average, roughly how long do you think people would spend at the gym? Well, go ahead and ballpark it. What do you think? What do you think our average would be? Like I definitely see, I had that 16-minute guy. Where did he go? 16-minute guy. But most of these values, it looks like, are in the 40s, 50s, like a solid bit of 60s. So if I were going to be like estimating what my mean is, I would probably be somewhere around there. So good, come up with an estimate. Now I want to talk about sampling and how we could do this. So we'd say, great, we have the same scenario. We could average every number in the table. So this is one way. We could just find the population mean. Why do we even need to sample this stuff? Well, my reason is it sounds annoying. Like I don't want to enter all of these values into a table, and this is only 800 data values. Well, we live in the age of big data when a lot of times we're talking about millions, billions, trillions of data values, and how do we sift through that? Oh yeah, there's a person that spent 9 minutes. That's probably the least. Anyway, and I was going to say, in real life, you can't always do this. So if we think about what if we're interested in trees in Latvia for some reason? Well, we can't measure the height or age of every tree in Latvia, which means we can't come up with population statistics for Latvia for the trees. We would have to have a sample and come up with sample statistics and assume the population follows the same trend. So about sampling, here's my next questions. On a scale of 1 to 10, how much would you trust a sample of 5 pieces of data? So if I just choose 5 random pieces, I don't know, I'll choose this one and this one and this one and this one and this one. How likely is it those 5 pieces of data represent the entire population well? Well, what if instead of 5 pieces, we chose 20 pieces of data? So now instead of those 5, I'm going to add 15 more. This and this and this and this. 5, that's 10, and whatever, 10 more. So now we have 20 pieces of data. Well, how much do you trust that sample to represent the whole data? Or if we had 50 pieces of data, if I could just kept choosing and I chose 50 of all of these data pieces, whatever, I don't know, some of these aren't on the data because I'm just randomly clicking. What if we had 50 different data pieces chosen? Would you trust that more or less than the 5 pieces? I want you to answer these questions. Scale of 1 to 10, let's say 1 says you do not trust the sample to represent the population. 10 being you absolutely trust it to represent the population. So how much would you trust 5 pieces of data, 20 pieces, and 50 pieces? Come up with those 3 numbers. Pause the video, answer that. And now that you have numbers for how much you trust the data, here's my real question. When the sample size increased, when it went from 5 to 20 or 20 to 50, what happened to your trust in the reliability? I hope your trust should increase with the sample size. On top of that, there's an important word that goes with this. That's because the word is sample variability decreases. The idea of sample variability is if we only chose 5 data points up here, maybe I could choose the 5 data points that are like 9 and 16 and 22 and 23 and 24, and I just end up choosing 5 pieces of data that are all really low. Well, that means there's a variability, like there's a lot of variation. I could choose the low data values or the high data values. But if I choose 50 pieces of data, most likely I'm going to get both low and high data values. So there's less variability, like everything trends towards the middle. So sample variability is the idea. Given that, oh yeah. Oh no, given that, actually, I think you guys can come and answer this first set of questions. If you read this, you'll see the difference in these is that here we have a sample size of 5 for each data point. So they chose 5 data points here, 5 data points here, 5 data points here, and averaged those 5 data points. These are the averages. Same thing with 15, and they describe the same thing here. So with 15 data points, and they chose 15 data points for each of these. This is the average of 15 data points. So we have a bunch of different averages here. Based on that, answer these questions. Best of luck. I think you'll be capable. So just pause the video, answer them, and then start me again when you're done. All right, now that you're back after answering those, I want to talk about this next part. So it's talking about selecting a 3-digit number from the table of random digits. I want to make sure that you know how to select. We're basically going to use this table of random digits in order to select data values here perfectly randomly. You do have to trust this data table is perfectly random, and it's more or less, it kind of is. It's as close as humans are able to get right now. Randomness is a very, very difficult thing to do. So I'm going to choose a random place in here, just some location. You could just not look and point at the paper, or the activity says to use the eraser end of your pencil to point at it, whatever. Let's say I chose this 4. So if I chose that 4, we're going to make it into a 3-digit number. So I'm going to choose 488, and it's whatever number you choose, just go for the 3-digit number after it. And we're going to choose data value number 488. So it's nice that this gym data is organized, because data number 488 is in line 48. It's the 8th data. So 1, 2, 3, 4, 5, 6, 7, 8. That's 488 is data value 51. So when I come here, this talks about just filling in what number did we get? Well, we got the number 488. Then, wait, am I right? This digit in the following two, right? The value of first observation in your sample. So number 488 gave us data value, I forgot already, data value 51. So 51 is that data type. Then you're going to go on and just continue choosing more and more of these to get more and more of these, but only list the gym data down here. So maybe the next one I choose is that, what I think there was a 6. Maybe it was a 16. Maybe the next one I choose is 80 minutes. And maybe the next one I choose is whatever. I would choose those data values using this, using that table of random data. But then I'm only listing the data that I got. And so list those data. You should have 15 total data values when you're done with this question. So go ahead, generate your 15 random data values, and then come back. Hey there, now that you're back, you have 15 random data values here. So great, calculate the mean and do that. And now we need a way to share these things out. So I'm just gonna say you are able to get a hold of each other. It would be nice if we were able to have everyone's data all at the same time, but I know in distance learning that's difficult. So let's just say instead of sample means for everyone, I want you to get at least five data samples from others. With yours, that should make a total of 6 data samples. So good. Then you'll have 6 data samples to work with here. And when we go down, come on, to the next tasks, that means this part you will have 6 dots in your dot plot, and you'll go on and answer the rest of these questions. So great. I think that is the last thing I had to fill in for you guys, except for this question is just not going to be possible for us because of the way we've done distance learning, and that's fine. So question number 6, I want you to just cross it out and skip it. But other than that, you should have everything you need to answer the rest of the questions in here. And I want to just end by saying the important idea here is sample variability. It's the fact that the larger our sample gets, the more we can trust it. It also is harder to gather more data for a larger sample. So it's always a balance that statisticians are looking at is how much data do we need to decrease the sample variability in order to be able to trust our data, and at the same time, like, what's the least data that we need in order to be able to trust it, because it makes our job easier. Best of luck, Sevens, and I'll talk to you guys soon.